Bismillahirrahmanirrahim. Determine the Y parameters for the two-port network shown in figure 1. So we need to determine the Y parameters or the admittance parameters for the given network. So first of all, let's write down the equations for the Y parameters. So the equation for the Y parameter, I1 is equal to Y11 V1 plus Y12 V2, equation 1, and the second equation I2 is equal to Y21 V1 plus Y22 V2. So either we need to produce two equations from the circuit like these ones, and then we can compare the coefficients of V1 and V2 to find out the admittance parameters, or otherwise we can use the standard method to find the parameters. For example, we can first put V2 is equal to 0. This will eliminate these two terms, and then we can find Y11 and Y21. And in the second phase we can put V1 is equal to 0, so these two terms will disappear, and in that case we will be able to find Y12 and Y22. So let us explore both the methods. Method 1. So first of all, let us redraw this figure and label the I1 and I2 and V1 and V2 in the diagram. So let me redraw it here, right again. So this is 8 ohm resistor, then we have this 2 ohm, this is 4 ohm resistor, and we have this terminal, output terminal, and this is this controlled current source, and so this is input port, say, and this is V1, this is current I1, right? This current here is I2, this is voltage V2, and this current is I1, then this source is 2I1, right? So this controlled source depends upon the current here. So this is a current controlled current source. This is 2 ohm resistor. Let me call this fig 2, right? And let me name this node as V0 here. Let me call this the reference node. So we can apply, for example, a nodal analysis at V0, right? And we can write a node equation for this node. So KCL at V0 yields. So this is V0 minus V1 divided by 8, right? So V0 minus V1 divided by 8, and then V0 over 2, and this current is leaving here, so this is plus 2I1, right? And then V0 minus V2 divided by 4, plus V0 minus V2 divided by 4 is equal to 0, right? So let me call this equation 3. So if we see, this equation has three variables, V0, V1 and I1. If we want to write this equation in this form, then we have one extra parameter, which is V0. So V1 is there, but V2 is missing. So we have I1 also there, and V2 is also here, but V0 is an extra parameter here. So what we need to do is we need to express V0 in terms of the remaining two parameters. So applying KVL in this loop, right? KVL in this loop, KVL in left loop, gives, this is minus V1 plus 8I1, right? 8I1, and this voltage across this 2 ohm resistor is V0 plus V0 is equal to 0. So from here we can write V0 is equal to V1 minus 8I1. So these are the two desired parameters for this equation, this sort of equations. So putting 4 in 3 in this equation. So we have V0 substituted by V1 minus 8I1. So V1 minus 8I1 minus V1 divided by 8, right? Plus V0 over, V0, instead of V0 we need to put V1 minus 8I1 divided by 2. It would have been better if we would have used minus I1 here initially instead of V0 minus V1 divided by 8, because we will arrive at the same result, minus I1 here, right? You see that? So V1 minus 8I1 divided by 2 plus 2I1, and then plus, instead of V0 we write V1 minus 8I1 minus V2 divided by 4, and that is equal to 0, right? So let us now simplify this. So this cancels out, so this is minus I1, right? 8 cancels with 8, and this is plus V1 minus 8I1 divided by 2 plus 2I1, and this is plus V1 minus V2 minus 8I1 divided by 4, and that is equal to 0. So multiplying throughout with 4, right? So this gives us minus 4I1 plus 2V1 minus 16I1 plus 8I1 plus V1 minus V2 minus 8I1 is equal to 0, right? So minus 4I1 and then minus 16I1, so that is minus 20I1, and this 8I1 with minus 8I1, this cancels out, right? So we have minus 20I1. Let's look at this again. Minus 4I1 minus 16I1, and we have no other I1 terms left, and then we have plus 2V1 and plus V1, that is 3V1, right? And then we have this minus V2 is equal to 0. So you see we can now arrange this in this form. So 20I1 is equal to 3V1 minus V2. So I1 is equal to 3 over 20 V1 minus 1 over 20 V2. So let me call this equation 5, right? So comparing this equation with this one, we see that Y11 is equal to 3 over 20 and Y12 is equal to minus 1 over 20 Simons. So let's now try to write equation in this form. So let's apply KCL at this node, right? And let me call this node V2, right? This is V2, the voltage here is V2, right? So KCL at V2 gives, so this is I2, and that is equal to, this is flowing in here, so this is minus 2I1, right? And plus V2 minus V0 divided by 4, V2 minus V0 divided by 4. So let me call this equation number 6, right? So we can substitute the value for V0 here, and also for I0 here, I1 here, because we need to write this in this form, right? So I1 is not required in this equation, so we need to eliminate I1 and we need to eliminate V0. So we can substitute the value of V0 from here, and then we can eliminate I1 by substituting from here, right? So I2 let me write it down, putting or substituting 4 in 6. So I2 is equal to minus 2I1 plus V2 minus V0. So V0 is here, minus V1, and this is plus 8I1, and this is divided by 4. Let us see that again. So this is V2 here, and this is minus V0. So this is minus V0. So minus V1 plus 8I1, and that is divided by 4. So I2 is equal to minus 2I1, and we can multiply this whole thing with 4, right? So multiply by 4. So this is 4I2, and this is minus 8I1, and then this becomes V2 minus V1, and this plus 8I1. So this cancels out. So I1 is eliminated automatically. So we're left with, let's now divide this with 4 again. So this is I2 is equal to, let's put V1 first. So minus 1 over 4 V1 plus 1 over 4 V2. So we are lucky to have this second equation in this form, right? Let me call this equation number 7, right? And this Y21 is equal to minus 1 over 4, and Y22 is equal to 1 over 4. So we have all the 4 parameters, and we can write the Y parameters in this matrix form. So Y11 is 3 over 20 Simons. Y12 is minus 1 over 20 Simons. This is Y21 is minus 1 over 4 Simons, and Y22 is 1 over 4 Simons. So all the 4 parameters we have now. We can, if we require, we can write them in the decimal form. So 3 over 20, for example, is 3 divided by 20, 3 over 2. Basically it should be 0.15 Simons, and 1 divided by 20 is 0.05 minus 0.05 Simons, and minus 1 over 4 is minus 0.25 Simons, and this is 0.25 Simons, right? So we have all the 4 required parameters using this method. So we did not switch off V2 or V1 to find all these 4 parameters. However, we can imply that method as well. So let us try the second method also. So let me call that this method 2, or the standard method, or the standard method, right? Because the standard method will always give you the Y parameters, or the N parameters you are looking for. So we need to first put either V2 is equal to 0 or V1 is equal to 0. So let's go with V2 first. So let V2 is equal to 0. So what does it mean is that we short this output port, right? We short circuit this output port. So when this is short circuited, the voltage here is 0, because the short resistance of the short circuit is 0. So any current multiplied by this resistance 0 produces 0 voltage. So short circuiting V2. So short circuiting the output port. So let me redraw this figure here. So this is 4 ohm resistor, and we have this current source here, controlled current source here, right? And we are short circuiting this port. This current is I2, this current is I1, this is V1, and V2 is 0, right? This is 4 ohm, this is 8 ohm, 2 ohm, and this is 2I1, and let me call this fig 3, right? So let me call this voltage here V0, right? This voltage here, this node here, as V0. So again we apply KCL at this node, applying KCL at V0. So now note that this V0 is not the same as this V0 here, because in this case we did not short circuit the output port. So this V0 is different from this V0. And this I1 is different from the parameters shown here. So let's apply KCL at V0. So we have V0 minus V1 divided by 8, right, plus V0 over 2 and plus 2I1, right, plus V0 minus V2, and V2 is 0, so V0 minus 0 over 4, and that is equal to 0, right? So now I1 here is, let me call this equation, that was the equation number 7. Now let's call this equation number 8. So but I1 in this case is equal to V1 minus V0 divided by 8, right? I1 is equal to V1 minus V0 divided by 8. So 8 becomes, using this value, V0 minus V1 divided by 8 plus V0 over 2 plus 2 into V1 minus V0 divided by 8 plus V0 over 4 is equal to 0. So multiplying throughout by 8, multiplying by 8 we get, so this is V0 minus V1 plus 4V0 and plus 2 into V1 minus V0 plus 2V0 is equal to 0. So this gives us V naught minus V1 plus 4V naught plus 2V1 minus 2V naught plus 2V naught is equal to 0. So 2V1 minus 2V naught plus 2. So these two V naughts cancel out. So what we have is we have 2V1 minus V1. So that is V1 is equal to 4 plus 5. So this is minus, yes, this is 2 plus V1 and this is plus V1 plus 4V plus 5V naught. So this will be minus 5V naught. So let me call this equation 9. Right, so we have found out V1 in terms of V naught, and if we can find out I1 also in terms of V naught, so we can find the ratio I1 divided by V1, which will give us Y11, right? So I1 from here is, but I1 is equal to V1 minus V naught divided by 8. So we can put the value of V1 from here. So that will be minus 5V naught minus V naught divided by 8. So I1 is equal to, rather we should substitute the value of V naught, because we wanted to find the ratio of V1 and I1, but anyway we can divide, right? We express this in terms of V naught. V1 is also in terms of V naught, so we can then divide both of them to get the ratio I1 divided by V1. So we get minus 6 over 8 minus 6 over 8 V naught. So that is minus 3 over 4 V naught, right? So this is over 10. So dividing 10 by 9. So dividing 10 by 9, 10 I1 divided by V1, right, is equal to, so I1 is minus 3 over 4 V naught, and V1 is equal to minus 5 V naught. So that is 3 over 20 V naught. So Y11 is equal to, sorry, V naught is cancelled out, so we should write Moho or Simons, right? So 3 over 20 Simons. So this is the same value that we obtained here earlier, 3 over 20 Simons, right? So now KCL at V2, because the other parameter that we can now obtain is Y21. So Y21 is equal to I2 divided by V1 when V2 is equal to 0. So V2 is equal to 0 in this circuit, so we can determine Y21 also. So Y21 is equal to I2 divided by V1 while V2 is equal to 0. So KCL at V2 gives I2 is equal to this is minus 2I1, right? Minus 2I1, and this is plus V2 minus V naught. So V2 is 0 minus V naught divided by 4. So we already have V1 in terms of V naught expressed here, and we have I2 now in terms of I1 and V naught. So we can express I naught in terms of V naught using this here. So we can then have I2 in terms of V naught, and then using this ratio I2 divided by V1 we can get Y21. So putting this value, right? Using 10, using 10 we get I2 is equal to minus 2 into minus 3 over 4 V naught minus V naught over 4, right? So I2 is equal to, so minus minus cancels out, so 2 gives us 2 here, so that is 3 over 2 V naught, so that is 3 over 2 V naught minus V naught over 4, right? So this is 6 over 4 V naught minus V naught over 4, right? So this gives us I2 is equal to, so this is 3 over 2 minus 1 over 4, so this is 6 over 4 minus 1 over 4, so that will be 5 over 4 V naught, right? So this is equation number 10. So to get Y21, dividing 12 by, so V1 here was here 9, so I2 divided by V1, this will give us Y21, and this is equal to 5 over 4 V naught divided by minus 5 V naught, right? So Y21 is equal to minus 1 over 4, minus 1 over 4 Simons, so that is minus 0.25 Simons. Again, this is the same answer that we obtained here earlier. So we have now obtained two sets of parameters, Y11 and Y21, by setting V2 is equal to 0. To get the other two parameters, that is Y12 and Y22, we need to put V1 is equal to 0, right? So to get Y12 and Y22, we set V1 is equal to 0. That is, we short circuit the input port and then solve for the other two parameters. But remember that that circuit will be different now from this one. We cannot use any of these values used here in the second part of our calculations. However, in this method, this is not the case. We did not short any port, neither this one or not that one, so we used the value that we obtained here for V0 for determining all the parameters, right? So in this case, this value is universal and is applicable for the entire circuit for all the calculations that we are carrying out. But in this case, in the standard method, we have short circuited this port, output port first, and now we are going to short circuit the input port. So the values that we have arrived at here will not be used in the second part of our calculations. So let us proceed. Let's redraw this circuit and then short circuit the input port. So this was 8 ohm. This is I1 and we are short circuiting the input port. So this is V1 is equal to 0 now. And we have a 2 ohm resistor here. This is 4 ohm and we have a controlled current source connected here. And this is 2I1 and this is connected here. So this is current I2 and this is voltage V2, and let me call this fig 4. So 8 ohm resistance, then I1, that's V1 is shorted, this is 2 ohm, this is 4 ohm, this is 2I1, and this current flowing in is I2, and this is V2, right? V2 is an open at this time. So let me call this voltage here again as V0. And now V0 is, this V0 is not the same as this V0, right? And all these values that we used in method 2 cannot be used now in this part of the calculations. So let's apply KCL at V0. KCL at V0 gives, so this is 0 minus 8 or V0 minus 0 over 8, V0 minus 0 over 8 plus V0 over 2 plus 2I1, right, and plus V0 minus V2 over 4, and that is equal to 0. So at this node we have 4 currents. So this is 0 minus, if you assume this flowing away, we assume all the currents flowing away from V0. So V0 minus 0 divided by 8, this current, then V0 over 2, this current, then 2I1 flowing away, and then V0 minus V2 divided by 4, and that is equal to 0. So but I1 here, let me call this, this was our last equation number was 11 and 12. So let me call this equation 13. But I1 is equal to 0 minus V0, so minus V0 divided by 8. So I1 is equal to minus 0 minus V0 divided by, so that is minus V0 over 8. So this is V0 over 8 plus V0 over 2 plus 2 into minus V0 over 8 plus V0 minus V2 over 4 is equal to 0. So multiplying throughout by 8, we get V0 plus 4V0, and this just gives us minus 2V0 plus 2V0 minus 2V2 is equal to 0. So this minus 2V0, this plus 2V0 cancels out, and what we have is we have 5V0 minus 5V0 minus 2V2 is equal to 0, and that means 2V2 is equal to 2V2 is equal to 5V0 and V2 is equal to 5 over 2V0, right? So let me call this equation 14. So let's see that again. V0 plus 4V0, that is 5V0, and that is minus 2V2. So V2, 2V2 is equal to 5V0. So V2 is equal to 5 over 2V0. So we have expressed V0 in terms of, we have expressed V2 in terms of V0. So let us now apply KCL at V2. KCL at V2 gives, so that is I2 is equal to that is minus 2I1 plus V2 minus V naught, V2 minus 2I1 and minus 2I1, and then V2 minus V naught over 4. So we have only two currents here, and this is the third current. So this current flowing in is equal to this current, the negative of this current flowing in plus V2 minus V naught over 4. Okay. So we already have V2 expressed in terms of V naught, right? And we have I1 expressed in terms of V naught also. So using for example this value here, right? So but I1 is equal to minus V naught over 8. So I2 is equal to minus 2 into minus V naught over 8, right? And this is plus V2 minus V naught over 4. So that is I2 is equal to this minus minus becomes plus, so this is V naught over 4, right? And I2 is equal to yes, V naught over 4, right? Plus V2 minus V naught over 4. So V naught over 4, and this is minus V naught over 4, this will cancel out, and I2 becomes equal to V2, which does not seem to be correct. Let us revisit our calculations. So I applied KCL here at this node V naught, right? So V naught minus 0 over 8 plus V naught over 2 plus 2I1 plus V naught minus V2 over 4 is equal to 0, right? But I1 is equal to 0 minus V naught divided by 8. So V naught over 8 plus V naught over 2 plus 2 into minus plus 2 into minus V naught over 8 plus V naught minus V naught over 2, V2 over 4, V naught minus V2 over 4, right? So multiplying throughout by 8, so this becomes V naught plus 4 V naught, and this becomes minus 2 V naught, and this becomes 2 V naught minus 2 V2 is equal to 0, right? So this becomes V naught plus 4 V naught, this becomes 5 V naught, and this cancels out, and minus 2 V2 is equal to 0. So 2 V2 is equal to 5 V naught. So V2 5 over 2 V naught. So KCL at V2, this gives us minus I2 minus 2I1 and plus V2 minus V naught over 4 is equal to 0. So I2 is equal to minus 2I1 and plus V2 minus V naught over 4, right? So I1 here is equal to minus V naught over 8. So this becomes I2 is equal to minus 2 into minus V naught over 8, and this is plus V2 minus V2 is equal V2 minus V naught over 4, right? So this becomes V naught over 4, and this is V2, this is V2 minus V naught over 4. So I2 is equal to V naught over 4 plus V2 over 4, sorry, we are correct, V0 over 4. So this is okay, right? So this cancels out, this is perfectly alright. So I2 over V2 is equal to 1 over 4 Simons. So Y22 is equal to 1 over 4 Simons. So this is the answer that we already obtained. So we have been right all along. So Y22 is the same that we obtained earlier, the same answer that we obtained earlier, right? 0.25 Simons. So we left with to find Y12 now, right? Y12, because we have found Y11, Y21 when V2 was equal to 0, and we now need to find Y12, right? So Y12 is equal to I1 divided by V2 while V1 is equal to 0. So we already have expressed I1 in terms of V0, and we have expressed V2 in terms of V0, right? So let me call this equation, for example, this was 13, 14, let's call this equation 15. So using 15 and 14 and 15, right? Using 14 and 15, using 14 and 15, Y12 is equal to, the value of I1 is minus V0 divided by 8, right? And that of V2 is equal to 5 over 2 V0, right? So Y12 is equal to minus V0 over 8, and that will be divided by 5 over 2 V0. So that will be 2 over 5 V0. So Y12 is equal to minus 1 over 20 Simons. So Y12 is equal to minus 1 over 20 Simons, that is equal to minus 0.05 Simons, and that is the same answer that we obtained earlier, right here, right? Y12 minus 1 over 20 Simons. So let's then rewrite again this in this matrix form, all these parameters. So Y11 was found out to be 3 over 20 Simons. Y21 was found out to be minus 1 over 4 Simons. And then Y12 minus 1 over 20 Simons, minus 1 over 20 Simons, right? And this one is the same as here. And then Y22 is minus 1 over Y2 is 1 over plus 1 over 4 Simons, 1 over 4 Simons. So we have determined all the 4 parameters, admittance parameters, or the Y parameters, using both the methods. So this finishes this solution.